Well, I know you're missing my voice, so you probably just couldn't wait for this last review video today. Okay, this one is going to be about bonding. We're going to talk about different types of bonds, their properties, and then we're going to draw some Lewis dot structures. And that should cover most of what's in the unit. Again, none of these videos are covering every single detail. Otherwise, we wouldn't have taken weeks to learn it. We would have just watched a 10-minute review video. Okay, so types of bonds. There are three main different types of bonds, and all of this is oversimplified because it's just high school chemistry, but oh well, gotta start somewhere, right? So ionic, covalent, and metallic. And I think it's worth reviewing the different types of elements that are on the periodic table. Okay, this wasn't drawn very well. There's the periodic table. Okay, so generally, if it's on the left side of the periodic table, it's a metal. So anywhere on this side. If it's on the right side of the periodic table, it's a nonmetal. And then if you're in between, we'll do orange, I guess. If you're in between, oh, I should have done purple because red and blue. Ah, well, too late. Is a semimetal or a metalloid? Okay, so that's important to remember. So now let's take a look at these different types of bonds. So we've got ionic, covalent, and metallic. So ionic is when electrons transfer. And so in order for this to happen, you need a very high and a very low electronegativity. So one needs to be a metal and one needs to be a nonmetal. For covalent, you share electrons. And so share is a little deceiving because really they're having a tug of war over them. So they both have very high electronegativity. So it's two nonmetals. Metallic, the electrons wander. And so the electrons are not held on at all because they all have very low electronegativity. So this would be a metal with another metal, or a metal with itself. And this could be true of covalent too. You could have a nonmetal with itself, like hydrogen gas is H2 or oxygen gas is O2. Okay, now let's look at some characteristic properties. So let's look at, does it conduct electricity? Because this is related to the behavior of electrons. Ionic forms ions. So it will conduct only if dissolved, because those charges have to be able to move around. The electrons are locked in the atoms, but the atoms themselves gain charges because the electrons move. And so if you break the crystal, which is the structure, so structure is a crystal, which is a repeating pattern of positive and negative. If you break the structure, then those charges can then move around and conduct electricity, because moving charges is electricity. Covalent just don't conduct. Okay, these are molecules, the electrons are shared, the electrons cannot move around. There's some really interesting exceptions to this that we haven't studied and wouldn't make sense to you, but generally, covalent do not conduct electricity. So if I tell you it's covalent, I would expect you to say, no, it probably won't conduct electricity. And then metallic will always conduct electricity. These electrons are able to move around because they're wandering. The electronegativities are so low that they can't hold on to these charges, so they easily move around. Metals are some of the best conductors. And the structure is a malleable solid. There's one or two exceptions that are liquid at room or close to room temperature. They'll still conduct. Remember, malleable means bendable. So like a paperclip is bendable. Some metals are more bendable than others, obviously, but generally metals are going to be more bendable than ionic. If you bend a metal, It bends. If you try to bend a crystal, it just snaps. Okay. What about the melting point? Ionic bonds are very strong, which means they have a high melting point. Covalent bonds are weak, at least the molecules are not attracted to each other anyway, so they have a low melting point, and metallic is kind of in the middle. I'm sure you can find some exceptions where ionic has a lower melting point than a certain metal does, but we're talking in general here. The ionic bond is held together more strongly. What else? Melting point, conductivity, the structure, behavior of electrons. I don't know. I think those are the big ones. You can check in your notes if you need more differences, but those are the big ones for sure. So let's look at some Lewis dot structures. This is only for covalent. Lewis dot structure. Okay, so this is a way to show how the valence electrons are bonding together. So if you just have a single atom, like let's take carbon, its outer electrons, it has 6 total electrons, but those first 2 are on the first electron shell, so there's only 4 valence electrons, so we would draw them like that. Now, this is unstable, because it needs a full shell, which is called the octet rule. And so it's going to bond with something. So let's say it bonds with hydrogen. Okay, like this. Now, they both have high electronegativities, so they're not going to transfer electrons, but rather those electrons will meet in the middle and form a bond. This satisfies hydrogen's need to get a full shell because its first shell now has 2, and that's full. However, carbon still has 3 unpaired electrons. So we could do this. We could add more hydrogens. And I'm just picking elements at random. I'm just picking a very simple example for our first one here. We'll do a slightly more complex one next. Alright, so there we go. And so what we get is a carbon that makes a bond, or rather 4 single bonds, to hydrogen like this. And so this is showing how everything has a full shell and everything's happy. So a couple rules here. You want full shells. So that means either 2 or 8. Also, don't, how should I say this? Don't make up electrons. Okay, I'll say it this way. Only use what you start with. So here I started with a total of 8 electrons, 4 from carbon and then 1 from each hydrogen. And so here I have 4 bonds, 2 electrons each. I still have 8 electrons, so it's okay. Let's take another example. Let's take, let's do a more complex one. Let's take, oh, here's a good one. Hydrogen cyanide. Okay, this one's more complex. So I know hydrogen has 1 valence electron, carbon has 4, nitrogen has 5. And so I'm just going to start connecting these. Okay, so I connect the hydrogen and the carbon, I connect the nitrogen and the carbon. Carbon still has 2 more it needs to bond, nitrogen still has 2 more it needs to bond. And so I'm actually going to bond multiple sets between the same 2 elements. And so what I have here is I have a multi-bond, a triple bond in fact, between carbon and nitrogen, and I have this lone pair left over. So this is a triple bond. This is called a lone pair, because it's all alone. It's not bonded with anything. So sad. And this is a single bond. Alright, so this is how to draw Lewis dot structures. You could put this into steps, you know, draw the atoms by themselves, pair up electrons to get full shells, and only use what you start with. And sometimes you might have to guess and check. That's okay. I wouldn't expect you to get a molecule like this necessarily on the first try. This one's going to take longer than something like this. A little tip, notice how I put carbon in the center? Put the one that makes the most bonds in the center. Have fun.